Video number 2 in the series of 20 videos about electric motorcycles by DTD Auto Vietnam. Hi everyone. As part of the electric vehicle technical training series, this section continues to provide both an overview and detailed knowledge of the most important components of an electric motorcycle. The goal is to help technicians understand the structure, operating principles, and interconnection of systems, thereby enabling effective diagnostics and repairs. Initial statement: do not assume that repairing an electric motorcycle is easier than a gasoline one. In fact, for modern electric motorcycles, e.g. VINFAST VENTO-S, the technical complexity is much higher if the technician has not been properly trained. Gasoline motorcycles allow direct observation and handling of many mechanical parts, whereas electric motorcycles are almost entirely electronic systems, requiring a completely different approach and mindset. Two common groups of faults. Modern electric motorcycles often encounter faults mainly in the following two system groups. 1. Power supply system. This system includes lead-acid battery. Capacity: 3.5 Ah. Nominal voltage: 12 volts. Function: supplies 12 volts power to body systems, ECU and components that require 12 volts, similar to a gasoline motorcycle. Note: this source is not self-sustaining. It must be charged from the main battery via a DC to DC converter. Lithium-ion battery pack, main battery. Nominal voltage: 72 volt. Function: directly powers the wheel motor. Not related to the vehicle's 12 volts electrical system. DC to DC converter. Function: converts 72 volts DC from the lithium battery to around 13.8 volt to charge the lead-acid battery and maintain the 12 volts system's operation. Location: installed near the battery pack. Significance: ensures stable 12 volts supply for control circuits and loads. 2. Motor system and ECU control. Drive ECU role controls the wheel motor based on throttle sensor, brake switch, and power module temperature sensor signals. Structure: large power ECU integrating processing and control circuits. Main power and phase wires. Includes positive, negative, and three-phase wires UVW supplying the BLDC motor. The three phases are conceptually similar to the ACG system in gasoline motorcycles, but operate differently. Internal CAN bus communication. Two wires, CAN high, CAN low. Function: transfers data between the vehicle's electronic modules. Motor power control principle. Uses PWM, pulse width modulation. Voltage is not changed, instead, current is regulated by chopping it into pulses and varying the pulse width. PWM components. P. Pulse, electrical pulse. W. Width, pulse width. M. Modulation, modulation process. Control signals are calculated based on throttle sensor voltage and other inputs, e.g. brake switch. Battery Management System, BMS. We will operate on the Motoscan tab screen. The BMS is integrated within the lithium battery pack. Functions. Monitor voltage, current, and temperature of each cell. Manage charge, discharge processes. Prevent dangerous conditions, overvoltage, overcurrent, overheating. Feature. Always built into the battery pack, not removable. Operating parameter analysis. When connecting a diagnostic device via CAN bus, the system provides over 100 parameters, grouped as 1. Measured parameters. Direct readings from the vehicle. Example: current battery capacity equals 92%. 2. Calculated parameters. Derived from battery age, charge-discharge cycles, temperature, and design data. Example: calculated capacity equals 88%. 3. Comparative significance. Similar values. Battery is still good. Real capacity close to theoretical capacity. Large differences. Battery quality degraded. Special case. Displayed percent still high, but calculated value low. Possible sudden power loss, due to low usable capacity. Voltage analysis. At measurement points. Measurement points. Overall battery pack voltage. Voltage at the fuse. Voltage at the ADC input. Meaning: close values, good electrical contact, negligible contact resistance. Large differences. Resistance at a joint or connection, causing power loss and heat. Solution. Check, clean, and tighten connections. Improve contacts, to reduce resistance. Conclusion. Electric motorcycles use a fully electrical, electronic propulsion system. Technicians must understand the principles of the power system, motor ECU PWM BMS and parameter analysis methods. Battery quality and electrical connections can be assessed by comparing measured versus calculated values and analyzing voltages at key points. In the next video, we will share more parameters with you. Goodbye, and see you in the upcoming videos.